Oakley dokley. Change that. Anyone who was in my grade 9 class last year has seen this diagram. If you were not in my grade 9 class last year, I cannot guarantee you have seen this diagram. Therefore, I am going to use it to show you why trigonometry works very quickly. What did I just draw?
Triangle.
Describe it to me.
A right triangle, AFB.
It's a right triangle. You're going to call it AFB. Excellent, which means that's 90 degrees, right?
Yeah.
Okay. How far is that?
3 units.
3. How far is that? 4. Excellent. I've asked you to write me a ratio of BF compared to AF. 3 to 4. How else can you write it? 2 other ways. What are the 2 other ways you can write a ratio? Mrs. Bagcrumble taught you this in grade 3, except she had apples and oranges, or hats and baseball gloves, or something else. Stephen. As a fraction, 3 over 4, and as a decimal, 0.75, right? Every decimal is just a variable, is just a ratio. Strike what I just said. If I had editing power, I would go back on the recording and I would edit that out, and it would go, every decimal is a, then there'd be a, like on the announcements, and it would go, ratio, and it would sound different because I had edited my own voice in separately. But I don't care that much. I'm allowed to make mistakes. I can't be this gorgeous and this funny and not screw up sometimes. I can't be this gorgeous and this funny and not screw up sometimes. Better. All right. Everybody cool? Yeah? Good, right? Easy peasy lemon squeezy, yeah? Okay. Now, I'm going to continue that red line, but I'm going to change it in color to light blue. Pretend that the whole line is light blue. And I'm going to go up to there. Now,
That's like perfect.
the vertical line is now 9. This line is now 12. Compare CG to AG. 9 to 12, which is 9 over 12, which is 3/4, which is 0.75. Yeah? Amazing! Then we're going to use Dusty Rose. That's what I'm calling this color. Because I grew up with Crayola crayons, and they had stupid names for colors. That is 20. Up and down is 15. What's the comparison? 12 to 15. 12 over, I'm that idiot. 15 to 20. 15 over 20. 3 over 4, 0.75. Right? Now, what is the only actual thing No, it's a day that ends in Y that my computer doesn't work. So that's all of them. What is the only value in those 3 triangles that I have drawn that is shared by all 3 triangles? I want the thing that is actually in all 3 triangles. What is it, Luke?
Angle A.
Angle A. Does everybody understand? This angle right here, which I'm going to color in with forest green, is in all 3 triangles, yes? Okay. No matter what I did to the length of the legs, B never changed, did it? So, if I went all the way out 24 this way, how far up would I need to go? Because at 18. Why? Because 18 over 24 is 3 over 4, which is 0.75. The green value has never changed. Everybody cool? All of you have seen this before if you were in my class last year. This is why trig works. Size of the triangle doesn't matter. The only thing that matters are the angles involved, which is why I can draw a triangle this big on a piece of paper and build that roof. Everybody cool? Because the angle between that roof and that wall is going to be the same on that little tiny blueprint drawing and on the big full-size school. Okay? Okay. Now you're going to do some more writing. Turn your page to, should be page 50, 51, 52. It should be page 53. 52? Damn! It's all right. It's one of those days. It's a Monday. What? What about me? Well, you said Mr. Myers. You must need my attention. Okay. All right. The first day of trig is both exhilarating for me. Why? Why is the first day of trig so exhilarating for me? Somebody who was in my class last year should know this. Hurtful. I pay attention to you guys. Anish? Hallie? Derek Moe? Paul? Jess? Jessery? No? I'm trying to make tears come out of my eyes, and I've almost succeeded. Look, watch. See? A little bit. Can't quite cry on demand. I've been working on it. Anyway, trig is exhilarating for me because it's my favorite stuff. I love it. It's my favorite thing. I love trig. I cannot get enough of trig. I said that to you guys last week as well. I'm sure I did. But I teach the same class 3 times a day, so maybe I didn't say it to this block. Exhilarating, yes. Frustrating because it requires a significant amount of mechanical planning before we can actually get into the math. So everybody get out your calculator. If you did not bring a calculator, do not bother getting out your phone because it is a pain in the rear. Everybody get out a calculator. Does everybody have one? Lovely. Look at the screen of your calculator. Do not look at the buttons. Look only at the screen. The kids in my earlier class had some trouble with that instruction. On the screen, which is a gray rectangle, look and see if you can see the letters. The letter D or the three letters D, E, G. Does everybody's calculator show one of those things? If it does not show D or DEG, then it shows either R and rad or G and grad. Is there anybody that has one of those red options showing on their calculator right now? It's the first time ever. Oh my God.
I bet somebody has.
You go home tonight. You tell your dad that this whole class was already in degree mode. And he will do something like what I just did. But he's not as dramatic as me. He'll go, huh? Weird. Oh. Don't ask that! You don't need to! But it happens. Calculators get bumped in your bag and you get off that. All right? If you ever look at your calculator, ever in Math 10, ever, or in most of Math 11, unless you're in IB, and you see that it isn't D or DEG, you need to push the button on your calculator that has DRG. And you hit that button until you see D or DEG. Don't. Why? You don't need. Oh, man. Okay, good. Everybody good? Now, there are some calculators that are slightly different, but since the vast majority of us are okay, I'm stopping there. Is everybody all right? Okay. Now, next thing you need to do, the next frustrating thing for me. Everybody push the C, the clear button. So your calculator is showing you either a wholly blank screen or the number 0. Is everybody looking at that right now? Excellent. Now, push the button that says tan. No. It says tan. It says tan. Put your hand up if your screen wrote the word tan. All right. There's a proper name for your kind of calculator. I call that a forwards calculator, which means for all of trig, you just punch in what you see. If it didn't show the word tan, so you have no tan, like the Ghostbusters, then you have what I call a backward calculator. And you must do all the calculations we are about to do in the reverse order. Do I know what kind of calculator you have? No. So whose responsibility is it to figure out how their calculator works? Yours, since I have given you both methods. Everybody good? So, if you have a forward calculator, what are you going to punch to make this show up? You're going to push tan, 35, and the equal sign. If you have a backwards calculator, you are going to reverse that, but you can't start with an equal sign, so you do 35, tan. And you need not push equals, because you are only doing one calculation. And all of you should get the same value on your calculator. Tell me the first 3 digits. 0.700. Did everybody achieve a calculator screen that had 0.700269855 whatever? Everybody? Awesome. Now do that twice more. And give it to me at 3 decimal places. Who would like to do 15? Who's going to give me that? Yes, Jazreet. 2, 6, 7. Nice work. Who's going to do C? 1. Lovely. Now, what does this mean? This means that if you had an angle that was 35 degrees, right? We are comparing this side, x, to this side, y, yes? So x divided by y would be 0.700, yes? Which means x would be 700, y would be 1,000. It makes the fraction. Is everybody with me? What would it be if this were 15? What would this be? $267. Lovely. And if it was 45? No. I've told you y is 1,000, so what would x be? $1,000, because 1,000 divided by 1,000 would get me the 1. Is everybody good? When you use your calculator, it gives you the decimal because it already knows what will happen if you draw a 35-degree angle and connect it from a 90. It knows that that division is going to get you 0.700. Why? because it always gets you 0.700. No matter how big you make the triangle, that original angle that you start from is still 35. Capiche? All right. Turn the page over. You're smart kids. If tangent gets you a decimal, what do you notice here? I already have a decimal, which means I don't know the angle. So how do I find that? I reverse things. You use, if you look on your calculator, not on the buttons on the calculator, you will see tan -1. What is the word we use to describe -1 compared to +1? They are opposites, right? Inverses, even. This is the opposite of finding the decimal, which means this finds the angle. How do you work it? The exact same way, except you have to use tan -1, which means you have to use second or shift or whatever your calculator uses to change the button to what is printed on the machine. So this one, if you have a forward calculator, punch in exactly what you see. Second tan 0.75 equals. If you have a backwards calculator, you're going to reverse that order. 0.75 second tan. And what do you get? $36.86. Now, angles are much like SI, or imperial. They are not broken down into decimals. Angles, believe it or not, are broken down into minutes and seconds instead of decimals. So as a result of that, we round our angles off to the nearest degree, unless otherwise instructed. So 36.86 becomes 37 degrees. All right? Now, I'm going to do something weird with this negative. First of all, I want you to pretend like it's not there. Just do the tan, shift tan of B for 1.23. And tell me what that gives you. 51 degrees, right? The negative tells us where it is in a circle. And we're going to come back to that later. But for right now, you should be able to get 51. What's C? 68 degrees. Yay! Okay, we can all work our calculator. Next, we need to remember, for any specific angle, and by specific I mean one of the acute angles. So it can't be the 90. You can't use tan for the 90. Acute angles. The tangent ratio compares the opposite side to the adjacent side. What does opposite mean in reality? In math, we use the word opposite. What does it mean in real life? What are you doing with that triangle? No. I'll remind you again, the hypotenuse is opposite from the right angle. Across. And what does adjacent really mean? The side, in reality. Everybody cool? Good, you remember this stuff. Please notice, in question 3A, I care about angle A. Where is angle A? Right there. And I want you to tell me the tan the tan of angle A. What do you know about every tangent ratio? It's opposite over adjacent. So tan of A is O over A, correct? So what is opposite of A? 12. What is adjacent to A? 5. Nice work. Now, what happens if I move to B? I'm in a new spot, yes? Tangent equals opposite over adjacent, always. Tan equals O over A. But what is different here? You don't need the hypotenuse. We're only talking about tangent.
All the opposite sides are switched around.
The opposite and the adjacent sides are switched around. Why?
Because you're focusing on it.
Because you're looking at it from a new perspective. Everybody understand? So what is opposite of angle B? 5. What is adjacent? Excellent. Now, you're going to use that knowledge to tell me what those angles are. All of you already know how to do this. If you didn't know it before, you should know it now. 12 over 5 and 5 over 12 are ratios, but our calculator doesn't work well with ratios, does it? What does our calculator do when we hit tan? It gave us decimals, didn't it? So I must need decimals here. How do I make that a decimal? 12 divided by 5. Now, can you do it all in one step? You can. It's not that difficult. Angle A must equal the shift tan of 12 over 5, correct? But our calculator doesn't like 12 over 5. It wants decimals. So how can I use my calculator to get that as a decimal? I do 12 divided by 5, correct? But what must I remember when I'm punching it into my calculator? If I were to push second tan, what do I have to remember to do with that 12 and that 5? I have to put it in brackets. Because if I don't, Harmon, my calculator is going to say, well, you want the second tan of 12? And then you want to divide that by 5? That's crazy talk. With me? So that's why I want you to write down what you had to type into your calculator. Not what I have to type into my calculator. Not what your neighbor has to type into his or her calculator. You need to type in what you type into yours. So on my calculator, which is a forward calculator, I need to go second. A is going to equal second tan bracket 12 divided by 5 bracket equals. On my machine, what will I need to do for B? Second tan bracket 5 divided by 12 equals. Because my machine is a forward calculator. If you have a backwards calculator, you must do it the other way. Everybody attempt it. Everybody write down what their calculator shows. I'll write down the right answers in 2 seconds, and you can see if you did it right.
I didn't do trig to solve for angle B because I already.
Of course you didn't do trig to solve for angle B, because once you know angle A, you automatically know angle B, because angles add up to 180. But this is a trig unit, so please do so. Who has an angle for A for me? Harmon. 67. Who has an angle for B for me? 23. Is everybody cool with tan? Remind me again, because there were a few people in the class that had never done trig before. Are any of those people here? Oh, sweet. Okay, then it doesn't matter. You do matter. All right. So, I'm going to draw a symbol for you that is very important over here. Circle with a little line through the middle. That symbol is theta. It just means an angle. For whatever reason, well, I know the reason. The Greeks did a lot of work with geometry. We use Greek letters when we are doing geometry. That letter, theta, has been reserved to describe angles. Okay? All right. So it is the angle about which we care. All right? Because there's 3 angles in a triangle. Do we ever care about the 90 degree? No. We only care about the other 2. One of them we are working with. That's theta. The other one we don't care about. Everybody with me? So in this triangle, this first triangle, what am I searching for? I am searching for that value, yes? Which is an angle, yes? So the theta in this case is x. Once I know I am working with this angle, I now know where my opposites and adjacents are, correct? Opposite is across. So O equals 23. Right? Right?
Right.
No. I was yelling at the computer that time, Jalen. Because it wasn't writing. And what is A? Fitting. Since I need an angle, is this tan or shift tan? Shift tan. Everybody make it happen. It's what you just did. And what is your answer for theta? Yeah. Move over to the next one. Do you have a theta? Do you have an angle about which you care? What is it? X is not an angle, it's a side. 15. Once you realize that you care about angle 15, that sets up your opposites and adjacents. What is opposite from 15? So O equals X. What is adjacent to 15? 37. Now, if you write it out, you cannot ever do trig wrong. Tan theta equals O over A. What's theta? Theta equals 15. 15 equals O. What's O? X. What's A? 37. Hey, just like the unit we just did, there's a denominator. How do I get rid of it? Multiply. 37 times tan 15 will get me X. You're going to do that on your calculator right now and tell me what X is. Remember, if you have a backwards calculator, you got to go backwards. 15 tan times 37 equals. Who's got an answer for me? Jalem, hit me. 10? Straight up 10? 9.915, whatever. How many decimals do I usually like? 2. Well, Jalem, because I would like for you to send a rocket ship to Pluto. You with me? You know where the planet Pluto is, right? It's at the end of our universe. It's billions of kilometers away. You with me? Okay. So you do the trig to aim that rocket at Pluto, but you round it off to 10. Right? Okay. So on this little triangle, on this calculation, this would have to be, you've rounded it to 10, right? Which is really not quite what it is. Agreed? So I'm a little bit off, yeah? I'm just a little bit off. So by the time I get to you, I'm going to be a little bit more off, aren't I? Okay. What happens after I've gone billions of kilometers to that little bit? Right. And I've just spent billions of dollars to send a rocket ship to Pluto. Shouldn't I be exact? As exact as possible? I'm nice to you guys. I say 2 decimal places. I understand that. That's why we're having this discussion.
All right, so every question, are we going to send a rocket ship to Pluto?
Assume that, yes. And finally, in the third triangle, do I have a theta? An angle about which I care. 70. That sets me up for my O and my A. What's O? What's A? Tan theta equals O over A. Tan 70 equals O. 14 over AX. The number's on top now, so we do 14 divided by tan 70 to get our answer. Now, once again, this is where it is most difficult if you have a backwards calculator, because you can't just reverse it, can you? You must, and this is the only time I'm going to help you with this, 14 divided by 70 tan, and then a bunch of you are going to forget to hit the equal sign, because when you hit 70 tan, your calculator screen changes, doesn't it? But you haven't told your calculator to give you the answer yet, have you? What tells your calculator to give you the answer? Equals. You must hit equals. Tell me what that answer is. 5.095, so 5.1. Of course I rounded. 5.095 rounds to 5.10. Right? Because this is math class, and we know how to round. Uh-huh. But a lot less off than if I rounded it to 5. Not maybe. There's no maybe about it. Rounding it to 5, I rounded it by 1/1000th of what it was. You rounded it by 1/10, which is cubically bigger. Yes, I'm aware of that, but I'm going to be millions of meters closer than you will be. My rocket ship will get a picture of Pluto. Your rocket ship will be, I think that's it, right? Oh, damn. Which one are they going to pay me for? Your blurry pictures of Pluto while you fly by on the wrong side of the solar system, or mine that actually shows? Here's a question that has 2 unknowns, which means we must find 2 things. Do we change our methods? Of course not. Do we have an angle about which we care? Yeah. What is it? 30. What else do I have? 24. What is 24 compared to that 30? I have an adjacent of 24. What else do I have? I have an opposite of x and an hypotenuse of y. Well, how do you get the question? You notice that you have A and O, so that means you can do what work? Tan 30 equals x over 24. Correct? What? Do not enter this onto your calculator yet. How would you solve that algebraically? 24 tan 30, correct? Now, if you do that on your calculator, as Jayla and I have just been having an educated discussion about, I'm going to get a yucky decimal, aren't I? That yucky decimal requires some rounding at some point. When? As soon as I hit the button? Or later? Should be later, shouldn't it? because we are going to use that value to solve for y, aren't we? So we know that this is 24 tan 30, which we know is going to give us a decimal, yes? Do that on your calculator. Do not write down anything. I will show you what I mean. $13.856406466, right? Everybody with me? Right now, you want to round that off to 13.86, yes? Of course you do. But to be as exact as possible, we need that value, don't we? How are we going to use that value to find the hypotenuse?
Well, now that we have that side, we know that y is going to be the opposite of x. So we have the value of x now.
You would just do Pythagoras.
Oh, yeah.
Right? So once we know that, I'm not even going to go to my calculator yet, because what happens when I go to my calculator? What is the potential to happen every time? Press the wrong button. So if I can do more work in my brain, I know that's the value of x, don't I? What else do I know? I know that 24 squared plus, not x squared, 24 tan 30 squared will equal y squared, yes? So now, could I consider going to my calculator? If I punch that in, go to my calculator, 24 squared plus, I'm going to use brackets, 24 tan 30, close brackets, squared, equals. Now, I can go square root 584. And if I round that, I get the best possible answer. Is everybody with me? Now, if you round here, you're going to get an answer very close to mine, which in math class is fine. But that's not the way you would want to do it in real life if you were ever working this stuff out. And let me give you an example of people who do this stuff in real life. How many of you ever seen the people on the side of the road looking through the little telescope at the other person on the side of the road way far away? You've never seen that.
The telescope? Is that for the leveling scope?
Leveling, surveying, anything. Those people are doing grade 10 trig and being paid buckets of money to do so. Buckets of money to do, look through it, lens at somebody else, fire a laser at them, and do some trig. Buckets of money. And since that's all we care about in North America, some of you may want to consider paying attention to this unit and becoming surveyors later in life. Everybody cool? Now, what if I round this off? We all know that this answer is 24.17, yes? You can see it on my machine, right? So that is the best answer. But if I do this, 24 tan 30, and I round that off to 13.86, then I go back to my calculator, and I go 24 squared plus 13.86 squared equals, wait a cotton picking minute. What happened? What happened with the way I punched that in before? Because that should have worked. Well, why didn't you guys stop?
You squared it and then...
Oh, no!
Yeah, see, that's what I got. Look at my calculator.
My calculator gave me an answer that I continued to work with. Should I have?
No.
Why? What's missing? What did I start with?
24 squares.
What did I start with? My calculator needs a second bracket, doesn't it? Did I put it there? Now, you all just saw what you all are going to do. What did I automatically believe? I believe my calculator was right. Did I hit all the right buttons?
Yeah.
I have everything from the question, don't I? But forgetting how my calculator worked caused me to get totally the wrong answer, didn't it? Right? So when I go through this thing to talk about how your machine works, you got to know that. So if I change this around to whatever I had, it was 768. So I should have had second root, second answer. It should have been 27.71.
Yeah, I love that.
Now, 1 second. What would have been my hint if I was doing this work myself, not in front of you guys? Why would I never have handed in that?
Because you don't have your work on the page.
That gave me an answer of y as 13.86, didn't it? Couldn't y possibly be 13.86? Why not? Smaller than 24. So now, when I check, now, if I want to punch it all in at once, 24 squared. Now I've recognized, oh, I know where I went wrong. Bracket, 24, tan, 30, close brackets, squared. 768. Yes, you can. Right? I'm just saying that as you get further along, if your calculator doesn't show everything you do, once you finish and push clear, it's disappeared forever. And a great many of you refuse to write stuff down still. That's what I'm trying to say. If you're going to be like that, you're best to leave it alone until it's time to use. All right, so now, when my computer thaws, you guys should have 3 triangles at the bottom of whatever page we are on right now, because obviously my numbers are different than yours. Do you? Yeah, I understand that. So right now you should be looking at 3 triangles on whatever page you are on. Are you? Great, solve them. Tell me the missing values while my calculator or while my computer waits to, do what it's supposed to do. Oh, I'm sorry. Yes, OneNote is cleaning up from the last time it was open because it was such a mess. Remember, if you write it out, you can't do it wrong. Who has an answer for the first one for me? 35. Absolutely correct. Now, does my calculator show me 12.12 there? Yes or no? No, it shows me a big giant number, yes? Am I going to use that number later? Yes. So here's what I would recommend to you guys. When you need that x, like you do in the question, round it off, write your answer. But leave it the giant number on your calculator screen, because you're going to use it again later, yeah? Because right down here, I know I needed this is this. It's already on my calculator screen. So when I write out my next step, I know, 12.12, blah, blah, blah. It's already on my machine. So I just push squared plus 7 squared and then square root the answer, which is what? Exactly? 7 squared plus 7 tan 60 squared. Yes, it is 14 exactly. Look at that. That's hot. And over here, what's your answer? What's your answer? Answer? 1.76. Now, you guys should be looking at a white page that says angles in the real world now. Because are any of these angles in the real world? Are they? It's a triangle written on a piece of paper. Is that a real world angle?
No, but
Okay. Exactly. In the real world, we discuss, we need to know where the angle is. And this is what we use. Here is, that's a bad drawing. Here is my eye. Everybody agree? My eye can look straight, level. Assume that's perfectly horizontal. Everybody agree? Okay. This is what is going in angles in the real world. Right? So my eye looks out level. Right now, my eye looking straight at Luke. We're going to play stare eyes. I'm going to lose because I'm old. Oh, I won. Wow. Anyway, I'm looking right at Luke. Yes? All right. Hallie shoots off a firework. Where do my eyes go? Up. So Hallie shoots off a firework. Right? And my eye then looks up. What did I just make right there? I made an angle. Since my eye went up, I made an angle of elevation or inclination, because my eye went from level to up. Everybody with me? All right. After Hallie throws a firework in the air, she drops a firecracker, because she's a bad kid. None of you know what firecrackers look like because you're good kids.
I know what firecrackers look like.
She drops a firecracker on the ground. And what does it do? Goes bang! And what do? I look down at the firecracker. creating what?
Another
A different angle. Since my eyes went down, we call that the angle of depression. Or declination.
I'm gonna stick with depression.
Most kids do because they say, when I'm depressed, I feel down. All right? Now, here is the problem. That's very easy to describe, yes? Now, you should have a little bit more room. I should have warned you not to draw this on the whole page. Let's draw another situation. Draw the ground. I'm going to draw the ground with a nice green line because the ground is beautiful and green. Now, I'm going to draw a very handsome fellow.
Just start with the circle. Oh. It's like a mad scientist. That could be a logo for something. Never mind, it's not a logo.
Handsome fellow on the ground. That handsome fellow, like all boys everywhere, and I know I shouldn't make that generalization, that handsome fellow hears a plane flying overhead. What do we all do? All of us. All us boys look up. My daughter doesn't look up at planes as much as my son. But boys, ooh, plane. Right? Doesn't matter what you do. Middle of a rugby game. Helicopter. Always. Anyway. Where have my eyes gone? Up. Which gives me a theta, which is an angle of? Excellent. Now, the pilot sees this super handsome guy on the ground. Where do his eyes go? Where were they looking before he saw the handsome guy? They were looking this way into the sky.
You made a Z.
Where his eyes... Ooh, look at that handsome guy down on the ground. There's his theta. That is the angle of depression. What do you know about those two angles? They're the same. The problem that you are all going to make when I give you these questions is you are going to tell me that the angle of depression for the guy in the plane is here. Nowhere. You're going to tell me that this is the guy in the plane's angle of depression. Because apparently he's turned the plane to crash straight into the handsome guy on the ground and is looking at something else down here.
Ooh, a penny.
Yes, he sees a penny. He's like, I'm going to get that handsome guy there. Ooh, penny. Ooh, shiny thing. Okay, this is nothing. It is neither an angle of elevation nor an angle of depression. It's just a third angle in a triangle. Got it?
Could it technically be his elevation? If
No. That angle is nothing. Just like this angle is nothing. Okay? Angles of depression and angles of elevation come from the eye of the observer. And they start horizontal and they either go up. So it's where my face is right now is an angle of elevation. Or they go down. And where my face is now is angle of depression. Wait, angle of depression. Okay? Is everybody good? Great. Now listen to me and listen to me closely. You do indeed. You have a test tomorrow. by Wednesday, Woden's Day. Now, please, what is your next page? It's got a bird at the bottom, yeah? What page number is it? 55. And I get that changed. This is the first of the homework that I have given you that has the answers. Why are they there? To check your work. Why am I not going to mark it? Because you've all got the answers right there. You all got 100%. So it's useless. This page, which for you is 55, your page 55 is due on Woden's Day, which is Wednesday. If you wish, you have, there's only 5 minutes left in class. Tomorrow, if you finish your test early, what should you do? Start on this page, then you'll have no homework tomorrow night. You have no homework tonight except to be ready for your test tomorrow. But since I assigned that test last week, you're all already ready, and tonight it's like, I got this.
It's an extra easy review.
Right?
Probably did.